This is the only other review video I will make for this exam, and I start off with my recommended steps for being able to identify a transformed sine or cosine function using its graph. And the first thing, see the graph down here, the first thing we should do is draw the top and bottom lines, and that will allow us to locate both the baseline, which is the b in this formula, and determine the amplitude, which is the distance from the top line or bottom line to the baseline, which is the a in this expression. So here's our top and bottom lines, and the baseline, as I call it, is going to be immediately halfway in between those two lines. And then if you count the distance from this line to this line, you'll see that it's 1.5, 1.5. Next, and I think this may be the exact function that I showed you earlier for graphing, I don't remember actually. But next, we measure the distance between the beginning and ending points of one cycle to determine the period. And so we choose one of these points, any point here and here, or here and here, or here and here. And so I'm going to choose this point, and then that makes this point here the end of the period. And then you measure that distance, and that is your period. And the distance between pi over 3 and pi is 2 pi over 3. Then you set that distance equal to the formula for a period, which is 2 pi over omega. That's the formula for sine and cosine functions. And so you can just see. You don't have to do any, so to speak, math here. You don't have to do any algebra. You can just see that 3 and omega are equal. And now, even though we know the function's period from measuring this distance, we still need to know something about the function's phase shift in order to determine a specific transformed sine or cosine function from the graph. Otherwise, there are infinitely many functions that would fit that graph, so that the phase shifts could start here, or it could start here, or any point where the function intersects the baseline on the entire function. So actually it wouldn't have to intersect the baseline. It could intersect the top line or the bottom line or any line in between. But there would be infinitely many, so we need to know something about that phase shift. And so for your exam question, you will be given this omega, and then if you plug that into this simple formula here, that will tell you where the beginning point of your period is. And finally, if that first point lies on the baseline, then the graph is going to be of a transformed sine function. If that point lies on the top or bottom line, then you have a translated cosine function. Okay, now for the remainder of this video, I'm going to go through the review that I posted. I posted online last night, and I'll just throw out some quick notes. These are the types of questions that you need to answer on the exam. This first part, has questions that you can use a calculator for. So if you're given the sine and cosine of a certain angle, then you want to identify the others, and you should be able to do that with complementary angles and reciprocals and whatnot. Now let's say you're given the length of one side and one angle of a right triangle. Well, you want to identify the other acute angle and the lengths of the other sides. Well, if you're given this angle, then you just subtract that angle from 90, and that will give you the measure of this angle. Vice versa, if you were given this angle here, subtract it from 90, and that will give you this angle here. And for the lengths of the sides, and for this applies to trigonometric function values. Just remember that the hypotenuse is also the c in the a squared plus b squared equals c squared of the Pythagorean theorem. It also equals the radius, and this side equals the x, and this side equals the y, and this side is equal to the opposite, and this the adjacent, if our angle is this one here. So those are all the same, and you can interchange them in those fractions. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and etc. Now, next we're asked to identify the complement of a given angle. Complementary angles sum to 90 degrees or pi over 2 radians. So you just subtract that angle from one of those two values to get the complementary, the complement of a given angle. Next it says, given a point on the terminal side of an angle, identify its 6 trigonometric function values. And so for angles greater than 90 degrees or pi over 2, using the reference angle makes that easier, which reference angle I'll get to in a second. Now, given one trigonometric function value of an angle as a fraction and the quadrant in which the angle lies, you are asked to identify the other, another trigonometric function value. Well, because we are, because this angle is in quadrant 2, then that means the sine is going to be negative, and that's why cotangent is negative here. It's the sine over the cosine, and you can use those ratios. The x over r, and the y over r, and the y over x, and the x over y to determine that other function value. And so as it says here, remember cosine's negative in quadrants 2 and 3, and sine is negative in quadrants 3 and 4. Next, given an angle, we want to identify the reference angle. Reference angle is the positive acute angle between any angle that's greater than 90 degrees or pi over 2 and the x-axis. And don't forget that even an 89 degree angle is still acute. Next, we want to convert, we're asked to convert angles given in radians to degrees and angles given in degrees to radians. Remember my units conversion tip. Multiply fractions that follow the keep cancel pattern. So you have some angle in either degrees or radians. If you want to convert from radians to degrees, degrees is what you want to keep, radians is what you want to cancel. So you multiply this times that fraction to convert degrees to radians. You want to keep radians, that's what you want to end up with, so that's in the numerator and degrees are in the denominator. Next, we're asked to prepare or be prepared to sketch the graph of a piecewise defined function. That means using one function for one portion of the domain and one function for another, whatever functions are given and whichever domains are given. Now, if there's a gap in the domain as it is described, you leave the graph blank there. You don't do anything. Now, for this part of the exam, you are allowed to use a calculator. And so you would be prepared to give an explanation of how these values affect the graph of a trigonometric form, a function of this form right here. Sine, cosine, or tangent, they're all pretty similar in terms of the effects. And if you look at section 7.6 and section 7.8, 7.6 tells you about the amplitude and period, and 7.8 tells you about the phase shift, and this shows you which values are affected. Amplitude and period are affected by A for amplitude and omega for period, and phase shift involves the omega and the phi. Now, the next one says sketch the graphs of one or more transformed trigonometric functions, and you want to include at least the 5 key points and appropriate asymptotes. This is very important that you sketch the asymptotes. I believe I give in the instructions of the exam to draw the vertical asymptotes. The notion of 5 key points is discussed in section 7.6. You can find that on page 570. And use a given graph to identify a transformed trigonometric function. We just saw that. And completing a blank unit circle, you actually can't, you're not allowed to use your calculator for this. This is sort of a misprint or a typo or whatever you want to call it. This is the first thing that you do in the exam, and then you bring it to me, and then you can take the non-calculator part of the exam, and after I check the unit circle, I'll give it back to you and use it on the entire exam. And then last it says use your completed unit circle or your memory or whatever it is you need to identify tangent, cotangent, secant, cosecant, trigonometric function values using the sine and cosine from the unit circle. Okay, I think that's everything I've got to say, and good luck.